Hello everyone, welcome to the channel. I have covered LlamaIndex a lot on the channel in the last 1 year. It is one of the most popular framework to build your agentic software or AI powered applications specifically geared towards your enterprise data. In this video, I'm going to share with you a new feature from LlamaIndex which is called as a router query engine. We are going to implement it on our own sample data in free Google Colab, and I will also share the link of that Colab with you, which you can also readily implement quite easily. Now, if you want to learn more about LlamaIndex, please search my channel. I have done heaps of videos on LlamaIndex in the last 1 year or maybe 1.5 year, and you should find a lot of information around that. Now, what I'm going to do here is I'm going to implement this router query engine in LlamaIndex. Router query engine is quite an interesting and I would say useful concept from LlamaIndex. With router query engine, you can very intelligently route queries for document summarization and specific contextual retrieval quite easily. By using specialized query tools like vector index or summary index, this notebook will show you how you can generate summary, or you could get quite deep insights from your own enterprise data. Now, before I move forward, let me also introduce you to the sponsors of the video, who are AgentQL. AgentQL is a query language that turns any web page into a data source. With its Python SDK and live debugging tool, you can scrape and interact with web content. AgentQL works on any page, it is resilient, it is reusable, and it structures output according to the shape of your query, so please do check it out. Okay, so let me take you to my free Google Colab. You can also check it out. I will be using OpenAI's model, which is a paid option. So for that, you would need to go to platform.openai.com and grab your OpenAI's API key. I already have it and I have saved it in my secret here, as you can see. And now let me first install all the prerequisites, which include LlamaIndex, LlamaIndex embedding OpenAI, and a couple of other items which I might not use in this video, but always good to have them. Let's wait for this to get installed. This is going to take a couple of minutes. So prerequisites are installed. Next, let's import this nested async IO. Now, if you don't know what this is normally used in the notebook environment. So this code primarily is enabling asynchronous IO support in notebooks or any other async environment. First, we are importing this nest async IO, which is utility for enabling nested async IO. Then we are applying this nest underscore async dot apply. So this applies a patch to the async IO library to allow for nested use of await and asynchronous context manager. Because by default, Python's async IO library does not support nested event loops or awaiting on task from within the another task. So this limitation can cause issues when using async libraries within the Google Colab or any other similar Jupyter notebook. Because if you have already an event loop running, that is going to cause some issues there. Anyway, so now you know what exactly this is happening here. Let's load our data, and this is where LlamaIndex makes it so easy by providing various readers. So I'm just going to use this simple directory reader to grab my PDF file. So this PDF file, which I already have uploaded here, so if you click on this folder icon on the left, this is a PDF file which I have uploaded, and this looks like something where I have my own information, just a random information about myself, because models don't know about myself, so that is why I'm just putting it as a sample data. And there you go. So it has loaded the data. It also creates by splitting it into chunks, because that is where behind the scene some ragging or retrieval augmented generation is happening. So we are splitting this document. It's a very small one, so shouldn't be more than one splits, I guess. Let's specify our API key. So I'm just importing the data because I don't have to show my API key to you, and that is why I have saved it in secret, and now you can just import it here like this. Next, let's set our model. Now because we are using our own data, we need to convert it into numerical representation. So we need two models, one for LLM and second is the embedding model, which does the conversion of text into embeddings or numerical representation. So for the model, I'm using this GPT-4o mini, and for embedding, I'm just using this text embedding ADA model, which is quite a standard and very performant. So next up, let's specify our two engines, because that is how it works. LlamaIndex, so one for query, one for summary, and you can also define it as easily as this. So you see, after importing the libraries, we are specifying our summary engine and query engine. One for summarization the document, other for the querying the document, and then we can instantiate these query engines. And the good thing about LlamaIndex is that it is going to remain same for any other use case too, because it is quite modular, as you can see. And once that's done, you can simply issue or create your router. So a router will be routing the request. For summary, it will route it to summary engine, and for the query, it will route it to the query engine. And the way you define or create this router engine is simply by using this router query engine, by specifying the tool. And you can specify a lot of other tool from LlamaIndex. You can search the documentation. It is very performant. So let's test it out. First up, I'm just going to ask it a query that, for example, who is Fahad Mirza? Let's wait for it. There it goes. Because it is a query, so it has selected the query engine, the router. And then it has given me the response about myself, that who Fahad Mirza is, and all the information in the LLM's own words. And then if, for example, you ask it, summarize the document. So I'm just asking it, summarize the text. Now query router should summarize it to the router engine, or it says that now you see that it is selecting the query engine 0, which is our summary one. It has also given us the reason that the question specifically asks for a summarization, which corresponds directly to choice 1. There you go. This is a choice 0 and 1, because in this array, this is a item number 0, this is item number 1. So that is why when we set summary, it has selected the item 0. When we have asked for the query, it has selected the 1. So this is how you can define a lot of agentic tools here. Just put them in your router query engine, and then on the basis of your query, LLM is going to intelligently decide where to route the request. So this is how easy and good that is. And as I said, I will drop the link to it in video's description. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network, as it helps a lot. Thank you for watching.